In the future, the European Space Agency ESA will conduct a manned mission to Mars. Because of the risk involved in sending humans to the actual surface, missions with rover robots will be conducted first. The astronauts will remain in orbit of the planet in either a space station or a spacecraft and will control the rover from here. Our task is to design the overall look of and integrate the different components into a robotic rover platform. The rover will be used in a demonstrative Interact mission. During this demonstration, an astronaut will control the rover from the International Space Station, the ISS. The tasks are divided in work packages between two groups. We have focused on the following. Arm configuration. To ensure correct placement of the KUKA robotic arms, a test setup was made using an adjustable mount. The results of the test were used to plot reach envelopes for the KUKA robotic arms. The final mounts were made using aluminium tubing and aluminium plate material. These mounts will be connected to a bottom plate, which in turn will be placed onto the C-tracks of the symbiotic platform. Neck and vision system. The neck solution of the rover is the part that connects the vision system to the rest of the rover. The main function of the neck is to give the rover the ability to move its camera head between the positions of a driving mode and an operating mode. The selected robotic neck was the Shunk arm. To gain insight on how the cameras construct the vision of the rover when mounted on top of the Shunk arm, a prototype had been made. Power supply. For the power source of the rover assembly, a supply of at least 2000 watt of power is required, outputting a clean and steady 220 volt AC. The most suitable solution was to go for an electrical Clayton power battery system, providing a minimum of 2 hours usage. Head casing. The head casing protects delicate electronic components and brings aesthetical values to the overall design. The design of the head casing derived from a product experience research which tested the rover to human communication through facial expressions. Within the head casing there will be a mount on which the stereoscopic camera system will be fixed. This mount will be connected to the top of the Shunk robotic arm. Waterproofing. The Shunk robotic arm and the KUKA robotic arms are not water and dust resistant. Therefore a sleeve had to be devised to protect the arms from its environment. To keep the design of the arms intact, a stretch fabric was chosen. Using a stretch material also ensures the work envelope and rotation of individual joints of the robotic arms. The final design will therefore be made using a Bacchus stretch-light material. This material keeps out water and dust and enables full movement of the arms because it can stretch. The prototype used for testing was made out of a lycra material which mimics the stretch capabilities of stretch-light. The presence of human-like interactions in space exploration is becoming easier with the development of technologies and validations of projects like the Interact rover. With robotics, space is not the limit.